Hi everyone. Today we'll be solving this question: find missing and repeated values, or one of the question from Schreiber SD sheet. Find them repeat and the missing number from the given array or a matrix. So we are given an zero index 2D integer matrix grid of size n into n with values in the range of 1 comma 2 n square. Definitely it's a matrix, so n square. Each integer appears exactly once except a, which appear twice. Every integer here appears once, but only except one integer which appears twice, and one of the integer is also missing here. So our task is to find the missing and the repeated values. We have to find the missing number which is not present in the grid, and also the number which has been appearing twice here. So the example, if you see grade 1 3 2 2, you can definitely see this is the repeated value. So 2, at first we have to return the repeating number, therefore 2, and the missing number from here, of course, 1 2 3 4. 4, n is 4, therefore 4 is the missing number here, right? Again, if you see here, what's the repeated number? 9. 9 is once, again here twice, therefore 9 is the repeated number. 1 is also present, 2 is also present, 3 is also present, 4 is also present, 5 is not present, so the missing number here is 5. It's a very simple question. You can just use a hash set or a vector, anything, to find the frequency of the numbers. And then this is the first solution that comes to your mind, right? We can just sort it, and that way we can find the the repeated numbers, right? And another way is the first thing what it comes, like we will take a hash set, right? And then store all of the numbers in the present in the grid in the hash map or in a vector, and after that we will check the frequency and return according to that. So this is the things that comes to your mind at first, right? So if we have taken a vector of in count n into n plus 1, or you can take instead of count hash also. Okay, you can take a hash also here. So n into n plus 1 because 0 index. Now r is for the repeated number, m is for the missing number. So I have, this is a grid 2D matrix. Therefore for two for loops, definitely. And then I have taken the input of all of this number inside the hash map, right? And now I will check the frequency, right? So if hash of I is equals to 2, right? N into n because of the, it's a 2D matrix. If anything is equals to 2, that means the number have a frequency of 2. Therefore I will return it. But if anyone's frequency is 0 here, then that is the missing number, right? Frequency 2 means it is repeated, it is twice. If it is 0, that means it's not present, then I'll return. M is for the missing number, R is for the repeated numbers, as simple as that. Now looking to the another solution, the most optimal solution for this question, what it comes to your mind? Give a pause and think. So if you have just pause the video and give a thought, I hope you come up with the most optimal solution for this question. So this was the brute force, right? That directly came to your mind, or you can also find it by linear search, any of the searching method, right? So the time complexity here is big of 2n and 2, I don't know why I've written that. It's too big of n, like, see, sorry, because it's n square. Yeah, I was correct. Big of n square because two for loops here, and then again plus big of n, two for loops here, then again one for loop, and then s is equals to big of n into n because of the hash map that we have created a vector here. So this is the time complexity. What is the most optimal solution that comes to your mind? Now we have to reduce the space complexity by somehow, because this is a vector 2D integer matrix. Therefore this hash set is not gonna change. Definitely, sorry, the space is not gonna change. Sorry, the time complexity is not gonna change because n square, we have the 2D matrix here. But something we have to do with the space complexity. We have to remove this vector, this one, this extra vector that we are using to store the hash, the numbers present, right? So what can we get? See, if you have remembered early in our childhood days, we have been studying something called in natural numbers, first in natural numbers, and then we also have many things like the first square of first in natural numbers, right? So I'll show you the solution that I have done using maths for this particular question. So see, bachpan se, like from childhood, we have been studying one thing that the sum of first n natural number is n into n plus 1 by 2. The sum of first square of the n natural number is n into n plus 1 into 2n plus 1 by 6. Right? This is the formula for first natural sum of first n natural numbers and square of sum of first n natural numbers. This is the square and this is the sum. Okay, so from this we have come to a, like I'll show here. If you do this thing in your copy, you will arrive a formula. you know See, from equation 1 we have the sum of first a natural number, and then we have the sum of first square of sum of a natural numbers, and after that, if we form equation 2, we can conclude, we can come to a solution. Like if we combine both of these together in your copy, if you do that, we come with the formula, which is this: x is equals to this and y is equals to this. This is the main part. Everything is very easy. So I have taken this two formula, right? And I have also taken a is equals to 0, b is equals to 0. So a will have the sum of the first in natural numbers and b will have the square of the first in natural numbers. Therefore, this into the square, right? This is because for the square thing. B is holding the square of first in natural numbers. And then after we combine both of this equation together, S1 and S2, we come up with this particular three formulas. That is, sum is equals to b minus s minus 2 by a minus s1, and also x is equals to, x is basically the repeated missing number, sorry, the repeated number, and y is basically the repeated numbers. So if we put this formula, write these three formulas, and finally return the x and int y. This is the most optimal solution with space complexity of big O of 1 that we can come here finally in this question. And I hope you understood this question. See, it's very simple. Like we have this two formula you already know. Just tell this much in the interview, and after that this much you can do definitely. A is equals to 0, b is also equals to 0. A is alpha sum addition of the first n natural numbers, and b is the square of first n natural numbers. And after that we come with this three formula, which you can do in your copybook notebook, after playing with these two formulas, and then we return this. Finally, I hope you understood the solution. Thank you so much for watching. Bye.